Hello and welcome to another exciting Maya 2019 tutorial. Today we're going to be covering how to make a basic character rig by taking a production rig and repurposing it for video games. Now rigging's a hard subject and there's a lot to cover, but I'm going to break down the basic rigging tools by covering the geometry you need for a character, how to build a basic FK rig made out of joints. I'll be showing you my workflow for using the skin deformer, how to apply animations, and creating blend shapes to deform the face and make corrections to the skin. This tutorial is useful for anyone who wants an introduction to rigging or how to export a 3D character from Maya into a game engine. Now I'll be using Unreal, but I'll also be exporting everything using the FBX format, which will go into Unity or your preferred game engine of choice. I've added a lot of detail in the tutorial, especially the things that went wrong while I was exporting to Unreal. So feel free to skim through using the table of contents, and you can also leave me questions or comments below. If you like this video, then consider giving us a thumbs up, and if you want to learn more about animation, then consider coming over to Skillshare, where I've recently released a new class about how to animate using motion capture alongside with keyframes. You can get 2 months free premium access to Skillshare with this link, and it's a great class for anybody who wants to learn how to animate for video games where you need to use motion capture to create a large amount of animations very quickly. If you do want to support me and the channel, then really consider signing up, because you'll have access on Skillshare to all my classes about animation, and also it helps support me to make more videos for you guys. Also, that free membership is completely free, even if you cancel your membership before the 2 free months expire. I've recently started a new section on the channel called Quick Q&A, and if you like today's tutorial, I might consider making another section which I will call Maya Labs, where I will be trying to make creative and fun projects inside of 3D where I am not the expert. I'd like to dive into areas in the channel like trying to make renders for 3D animations using game engines, maybe do some 3D printing, or look into making some augmented reality stuff all using Maya, and some other software that I probably know nothing about, so you might see a few disasters along the way. If that sounds interesting, then I hope that at least by sharing my learning process with you guys, that you'll be able to see the wonderful things that you can create in the world of 3D, or at least it will be somewhat entertaining for you guys as well. So if you like that, please consider subscribing to the channel, hit the bell button, and receive all the notifications of when I'll be releasing my latest videos. So that's all for the channel updates. So today I'm going to focus on creating a character rig that I'm going to move from Maya into Unreal, and the fastest way probably of moving your animations is using Alembic, but I'm not going to do that in this tutorial just because Alembic would only play back the animation inside Unreal, and I don't think you can modify it after you've imported it. And who knows, maybe there's Datasmith or some other plugin that exists out there that might be able to solve this problem with a single button, but I'm going to go ahead and do it, so let's explore. It might be obvious, but the first problem is that the rigs that we use to animate in production have features that are not supported by the standard FBX format. So when we try to export them from Maya, we will instantly get all these notifications of things that have not been saved. And if we go further and try to import that FBX, even with its errors, into Unreal, the import will just fail. So I'm going to show you how to create a simple game rig that will take any animations we make with another production rig. In this case, I'll be using Franklin. The Franklin rig was made by Joshua Coate for Artella. You can check out more of his awesome work on ArtStation, and I'll apologize to him many times by completely ruining his work with the very quick and basic rig that I'm going to make during this tutorial. The workflow I'm going to use is going to be a bit strange because I'm going to be repurposing an existing asset that I haven't actually made, but it should hopefully highlight a lot of the problem solving and things that you need to create if you were making your own characters. I'll be going through this instead of spending the time of having to build my own production rig, which I really don't have the skills to actually do. And to start off with, we are going to select all of the geometry from Franklin, and we are going to delete its history. Remember that depending on what we want our character to do in the game engine, we might have to export objects like the eyes, the teeth, the tongue that might not be visible in the viewport. By going into Edit, delete by type history. We've unbound it from the rig, and then I can go into File, Export Selected, and save this as a file called Franklin Geo. After exporting all of the geometry, I'll open the file up because I'll see that there are some remnants of the geometry that I brought over, and there's some splines and groups which I will just go in and clean up quickly by going into the outliner, selecting the objects which are not meshes, and deleting them. After that, I'll save the file, and I have now all of the geometry from Franklin. I'm going to go ahead and build the joints for my new rig on top of the existing rig that Franklin has. I will have to go into the outliner, and I can select the view mode to display only joints, and I can navigate through the groups and find a group that is called rig, which is currently hidden. If I press Shift H to reveal the rig, all of a sudden I can see all of the bones in the viewport, and I can also turn the bones to be visible in the viewport display as well. Now Franklin's got a gap in his spine section where he hasn't got any bones because it's been set up as an IK spine over here. But I will still want to create points of articulation for when I create the joints later on. To help me with this, what I'm going to do is I'm going to create some locators to place in my scene, and I will align them with Franklin's spine rig. I'll basically align every locator to a point according to the rig's splines. And I can do this either by using a quick constraint where I can create a parent constraint without ticking off maintain offset box, and that will make the locator jump to the spline control, or I have an align script as well in Maya, which I can just align things very quickly this way as well. If you do choose the constraint method, remember to delete the constraint on the locator after you've created it. I'm then going to start creating the joint chain for the spine by clicking in the viewport. And I'll start off randomly because I want to show off a mistake later off, but I'm going to snap every single joint I create to the existing joints or locators by holding down V on the keyboard. This will snap every bone I create to an existing point in the viewport. After I've created my chain, I can come back down, and if I've made any mistakes, like I did at the beginning of the chain, I can press D on my keyboard to change the bone's pivot point, and I can actually move the joint around like a piece of elastic, and if I press and hold the V key on the keyboard, I can snap it straight to the hip joint. Now, it wouldn't be a tutorial about rigging if I really didn't stress how important it is to rename your joints as you go along. Not only does it make it easier for you to find things and avoid mistakes if you name things correctly from the start, but it's going to help with tools that Maya has, like mirroring joints. And even if we name our joints according to the naming convention that Unreal uses for its joints, we can save a lot of time when importing things, because Unreal will automatically detect what's the name of the joints and put them into the scene automatically, even though you could relabel them later on. With so much talking of names, even I made a mistake where I created two spine 1 joints, and this is something that definitely made Unreal freak out. I just had to go through and rename the joint chain correctly. To create the arm, I'm going to start off at the clavicle joint and work my way through the upper arm, lower arm, the hand, and then I can choose to go through any finger or thumb joint. I could start with the index joint, but in this case I decided to go down the thumb over here, and I make 3 points of articulation for every finger and just finish the finger off with a tip. To be able to create all of the fingers quickly, one of the things that I do is that I use the Create Joint tool, and I press V and snap and click very close to where the hand joint actually is. This will make my chain automatically link to the hand joint, and then I can go down and create a second finger, in this case the index finger. The beauty of this as well is that you can use your keyboard shortcuts to speed up your workflow. If I press G on my keyboard, I can repeat the last command that I was using, and that is to create a bone joint. So if I'm quick with my keyboard shortcuts, I can very quickly snap by pressing V and G to repeat my last command, and I can quickly create all of the bones together. Now, if I ever make a mistake and my points don't connect correctly and I've got loose joints in my hierarchy, that's not a problem. I can always go into the outliner and I can click and drag a specific joint onto another joint, and that will parent it and put it in the right place of the hierarchy. So I can take, for example, the clavicle joint I made earlier, and I can just drag it onto the spine 3 joint to connect the upper part of the body. If you ever click the first joint in the hierarchy, it will light up every single other bone that's connected to it, so that way you can easily see if there's anything missing. Two ways you can quickly and effectively rename your joints is maybe using some of the name tools by going into Modify, Search and Replace Names, and there you can type out a parameter like joint and replace it for any name you might want to give it. In my case, I will use thumb, and then you can go into the outliner and just replace each specific joint number and orientation. Now, a slightly faster way, which you may prefer as well, is also you can select a joint, rename it in the outliner, and then you can copy it with Control-C, and then use the arrow keys to navigate through the outliner, and pressing enter you can replace the name and just paste the name in for the index finger, and then you just need to change the number. So you've got most of the name already copied, and you can just paste it into the rest of the joints, making minimal modifications. We'll also create the leg joints by going down the upper leg, lower leg, foot, ball, and leave the toes for the tip. And once we have this joint chain made, we can actually mirror these joints. You can copy and paste entire joint chains in the outliner by selecting the top of the hierarchy and just pressing Control-C and Control-V, but the orientation of these joint chains will be exactly the same. However, if we go into Skeleton, Mirror Joints, we have a few more useful tools. The first thing that I'm going to do is make sure that I am copying my leg joints in the YZ plane, and I'll check that it mirrors the orientation. If I want to, I can also be smart and add in a search for, which I'll type in _L, and replace it with an _R. That way I'm changing all the bone names at the same time that I'm mirroring from left to right. So just by pressing the apply button, I've copied and renamed my entire leg. If I leave the window open, you can even see that it's going to be a piece of cake just to select the start of the clavicle bone for the left arm, and I can also mirror the entire arm and hand over in a single click. So now I have got set up a very simple FK rig made out of a single joint chain. However, I do want to point out that this is not the only type of rig that I could send over to Unreal, and most game engines will allow different configurations and different levels of complexity to create more sophisticated types of characters. In Maya, you'll need to spend some time orienting the joints. To do this, I'll turn on Display, Transform Display, Local Rotation Axes, and this will bring up the rotation axes for every single joint in the chain. We can see the Z and Y axes are placed fairly randomly. If I don't spend time orienting these joints, you'll see that if we try to bend the arms, they move in different ways, and if I grab the spine, you'll see that I can't predictably rotate the entire joint chain. What I want to achieve is that by grabbing one axis, I can easily curl the spine one direction or another. So I'll be thinking about in which way I want to have my positive rotations and my negative rotations. It's a matter of personal preference, and you will find that by trial and error, you can experiment with different ways of setting up a rig in a way that feels comfortable to you. By going into the outliner and selecting all of the spine joints and going then into Skeleton, Orient Joints, we can choose how to configure the orientation. I'm not an expert in this setup at all, and you'll see me go back and forth multiple times. As long as you don't close the window and you keep pressing apply, you can change the joint orientations as many times as you like, and I'll settle on an orientation that I'm happy with. Now, the one thing that I do know is that we always want the primary axis to be the x-axis, and then we need to choose of whether we want to be rotating the y or the z-axis as a secondary axis. By using a combination of the viewport and looking at the rotations in the channel box, I can see if the rotation on the z-axis allows me to bend the spine forward in the way that I would want. If I get a negative number, I can very quickly change whether the value added to the joint is positive or negative with the drop-down menu there, but everything seems to be configured properly for now. Let's move on to the arms. Here, I prefer using the elbow as the choice of where my joint chain is going to bend. I like to think as the elbow bends, that's the positive axis that I want to use. And I also like to have the orientations mirrored between the left arm and the right arm. That means that when I move the arms, they'll move together. So if I grab both upper arm joints, the arms will lift up and down at the same time. I'll do a similar setup for the feet as well, where I'll choose the knee and actually use the knee's bending point as the main orientation as well. In the fingers, I am going to favor the orientation of the phalanges. The joints for each single finger as they curl in will be my primary axis. I'm not really going to worry that much about the movement of the fingers from side to side, as they really don't bend further from the base of their joint in either side of direction. So really just focus on making one strong curling direction for each finger and thumb, and the rest should fall into place. Always check all of your axes orientation. Even when I mirrored the joints from the hand from left and right, everything was perfectly fine in the arm. But if I look at the axes of the fingers, they look completely terrible and they've gone in complete random directions. However, it's just going to be a few quick clicks for me to select all of the finger chains and align them properly. It is possible to orient the tip joints as well with a little more configuration, but since I'm not going to add them into the skinning deformer for deformations, I'm really not going to be worrying about if tip joints are actually oriented in the right way. One of the features that I chose to include in the head was to create a series of extra joints to skin the eyes and the jaw. That way I can actually animate the joints and create motion for the eye line and the mouth opening and closing. This is something that I can control either in Maya or in Unreal, and it's very much up to you to choose how you want to deform the face. But creating joint chains to articulate the face further than what we had in our production rig is a possible way of bringing animation into a game engine. I'll now select the first joint in the outliner, and I will go to File, Export Selection, and save out the entire skeleton joint rig as a separate file so I can combine it with the geometry. So as a summary, as I go creating new joints in the viewport, Maya is going to assign its best guess at local orientation for its axes, but it's not really very good at it. You do have to go in and check the local rotations and make sure that they work in a way that's suitable for your animation. So let's start putting things together. I'm going to open the geometry file and I'm going to import the rig that we just made by going into File, Import. And when we've imported the bones, it's important to remove the namespace by going into Windows, General Editor, Namespace Editor. I'll select the Franklin skeleton, press Delete, and I will merge the file with the root. That will remove any namespaces that we have and leave the standard expected Unreal names for the joints. Selecting both the joint chain and the geometry, I can go up to Skin, Bind Skin, and choose Options, just to make sure that everything's bound to the hierarchy and the maximum influences. In my case, I like setting them to 2 to have as little as possible. And then I should have a very basic skin deformer applied to the mesh. So if I move any of the joints around, I have a very basic deformation for the skin. Now there's still a little bit of work that we have to do to make this look right, but now's a time that we can actually start sending our files over to Unreal to start testing. So over in Unreal, I can import my skeleton FBX. I haven't got any other configurations to choose from, and I'm not going to bind it to any existing character, which is inside of Unreal. I'm just going to hit import. Within the engine, our character will be split up into 3 parts. A skeleton, which is a collection of the named joints inside the engine. A skeletal mesh, which is the mesh plus the joint rig that we brought in. And it will also generate a physics asset for if we wanted to add collisions or create ragdoll animations, which we're not going to use at all in this tutorial. I named all the joints following Unreal's naming convention, so we won't need to remap any names over here, but you could create a joint chain with completely custom names and you just have to relabel them in Unreal. I also noticed that Franklin has some inverted normals on his sleeve, so if I head back to Maya and select the appropriate faces and grow my selection using Shift period, I can go into the Mesh Display menu and choose reverse to flip all the normals so they're displayed in the correct way. Now you'll notice that Franklin's materials don't translate over into Unreal, and this would be a bit easier if Franklin was textured with bitmap textures so that we could just import them into Unreal and that would give us a guide for his shaders. I'm now going to start painting the skin weights. If I select the face geometry and go into Skin, Paint Skin Weights, I can see the effect of each bone on the face geometry by showing up in these white and grey colours. The first thing I want to do is to weigh my geometry, and I want all the objects to follow the head joint to have an influence painted on them that is of a value of 1, the whitest color that we could possibly make a skin weight brush. So I can select all of the geometry like the hairline, the eyebrows, and I can go into the tool settings for the Paint Skin Weights tool to bring up my last used tool, and I can set them all to have a value of 1 by pressing this flood button. A common technique while painting skin weights is to add some keyframes to the head joint so that I can actually move it into a specific position and then scrub through the timeline to see the effect of my skinning without having to come out of the Paint Skin Weights tool. Now, painting weights is normally a time-consuming and normally a time when Maya chooses to crash quite often, so I recommend you save regularly. And may the Maya gods always be in your favor. I'm going to weigh each one of the eyes to the eye joint so that I can animate the eyes by rotating those joints, and I'll also weigh the lower teeth and the tongue together to the jaw joint. Coming over to the head geometry, I'm going to have to share the weight between the neck and the head joint. To make this process easier, I'm going to limit what I can select by selecting groups of vertices, by right-clicking, choosing vertices, and selecting specific vertices. That way I can only paint weight on the selection that I've actually made. If I press Y, I'll jump back into the Paint Skin Weights tool, and then I can go over and choose a specific value for the neck and the head. I can lock all of the other joint influences to make sure that the weight is only distributed between the neck and the head, and then I can select one of the specific bones and I can choose flood, and that will create a full % influence to the neck, and it'll create a very unnatural looking deformation currently. However, by jumping back down into selecting other vertices, I can come in and start smoothing out the effect. So I can create selections and assign them either to one joint or to the other, and then I can select the in-between vertices and start creating a transition by changing my flood type from replace to smooth. With a few clicks, we can get an average result, but later on we can use all of the other brushes inside of the Paint Skin Weights tool. Remember to turn your vertice selection off for this part, and you can actually paint in where you want the deformation to be. As I work my way across the body, I'll repeat the process of adding keyframes before I create my skin weights, so I can create some small animations for each joint of the arms. To weigh the arm, I'll remove all the weight from the joints this time, and what I'm going to do is add 100% of the influence to the upper arm by going into the Paint Weights tool and selecting Flood the upper arm joint with the entire weight. Locking all the other influences except the upper arm and the lower arm will allow me to balance the weight around the elbow more precisely. And I'm going to make a selection of vertices that start from the elbow all the way down, and then I'm going to flood the weight of those down to 1. I'll then make a selection of vertices around the elbow joint, and I will smooth those areas out with just a little bit of touching up the elbow with the brushes. I can then come in and make sure that I've got an accurate deformation for the elbow. Going down, I'm going to do the same thing with the fingers as well, and I will go systematically down, adding influence from the parent joint down to the child, and then smoothing around the joint that I just created. So I'm constantly pushing the influence down the joint chain until it's painted properly. What I find really useful about this workflow is that by having the influence on a single bone and then locking every single other bone and just balancing the weight between 2 bones at a time, I can create some really good deformations, which I think are much better than the ones that Skin tries to create by default. You also have the advantage that you're not constantly wondering where your weights are going to and seeing strange artifacts come up. It might be a little bit more time consuming, but I do tend to prefer the results that I get by working in this systematic method. From here onwards, I can constantly export updates to Franklin and test them out in Unreal. You can see I've gone ahead and made some colored shaders, but I'm not going to focus on how to make textures in Unreal, as there's a load of videos on YouTube that cover that subject in much more detail than I can. But just as a small intro, I have actually gone ahead and just made some simple colored materials. One advantage is if you've labeled your materials in Maya's Hypershade, the name of the materials will be displayed inside of Unreal, and you can use that as a guide to quickly make your textures. The shading model inside of Unreal is also a node-based texture editor as well, with very similar attributes to Maya as well. You'll see that there are some areas like base color, metalness, specular, roughness, and other types of terminology that should be familiar to you if you've learned a little bit about texturing. However, the way that Unreal creates and displays its materials is just slightly different. So we've reached the part where I want to connect my Franklin game rig to the Franklin production rig that we started off at the beginning of the tutorial. That way I can animate the production rig inside Maya and transfer all those animations into Unreal. There might be a better way of doing this, but I'm going to use Human IK by going into Windows, Animation Editors, Human IK. Now, Human IK is a system that came from Motion Builder, and I will have to pose my Franklin game rig in a T-pose so that it works with this system. The legs of the character have to be straight up in the Y-axis, and the arms have to be following the horizontal X-axes. I'm going to help myself by going into the orthographic views and turning on the rig and making sure that all the limbs are aligned correctly. Now that I've got Franklin set up, I will have to double-click on each joint section in the Human IK panel and then select the corresponding joint in the viewport. I will expand sections like the spine, neck, and fingers to be able to select and add them to the human IK system. I have a property that mirrors the selected joint selection, and when I select the left joint, it will also map the right joint if these have been named properly. But for areas like the hand, I might want to turn this off, as constantly going between left and right hand for every joint is far too time consuming. So I'll turn that off and do the whole left hand joints and then swap over in the viewport to do the right hand. Once my character definition is ready and I've got a green tick in the top right hand corner of Human IK, I will rename the character to Game Rig so it can be easily identifiable. And in true Blue Peter fashion, I will bring in an animation that I made earlier with Franklin's production rig, which I also connected to Human IK. Thanks to being able to create some motion capture and along with some custom keys, I've got a walk animation all ready to be connected to Franklin. So now that I have multiple Human IK characters available, I will hide everything except my game rig, which is still in its source T-pose. I will then choose the source to be the Franklin animation that I just brought in, and I can see my game rig now walking away with the original animation. My game rig is now animated, but what I have to do is save the keyframes by going into Bake, to Skeleton, and Maya will create a keyframe on every joint for every frame of the animation. And this is a normal way of baking out animations and sending them into game engines. A pro tip at this stage is that we actually only really need to export the skeleton to send the animation into Unreal. Even though we could clean up the file and send both the skeleton and the character mesh, we can reduce the overall file size by selecting the first joint in the skeleton chain and go into File, Export Selected. In your FBX settings, you will just need to tick the animation box, and you can also bake the animation here if you haven't done it previously. I created 3 animations to import into Unreal: an idle, a walk, and a run. If you want to learn more about how I created the animations for this tutorial using motion capture and keyframe animation, then come and check out my classes on Skillshare. Using this link, you can get a 2-month free Skillshare Premium membership and have unlimited access to every class on Skillshare. And you will get those 2 months completely free, even if you cancel your account before those 2 months are up. If you want to support the channel, please come over to Skillshare and check out some of my stuff. When importing the animation FBX files in Unreal, I will select the skeletal mesh that we made earlier when we were importing Franklin for the first time. That will connect all the animation files with the Franklin skeletal mesh, and we will have some animation files which will be color-coded green, and when I double click on them, the clip will load alongside the skeletal mesh so we can see the full animation on top of the joints. You can also notice how my skinning around the shoulders has not been too successful, but that's one of the great things of using motion capture alongside your rigs, which is that you can see the deformations that you need to create a little bit more clearly than the few keyframes I made in Maya. I can then head back into Maya, and I can actually use the Paint Skin Weights tool alongside with the animation. I can actually play through the entire file and paint on top of the bones that I require a further adjustment. Once everything's ready, I'll set Franklin again to a T-pose, and I will re-export the actual skeletal mesh and update it inside of Unreal. Back in Unreal, we can see that the shoulders now look a lot better, and I can continue to go back and forth between Maya and Unreal, fixing minor problems just as they go appearing. I'll also export an animation for the run and the idle, and I'll always be checking that the feet are in contact with the ground plane. Blend shapes are going to allow me to deform areas of the mesh, like the face, by storing the position of each vertex in 3D space. I can then deform the mesh between those 2 values. It is important when creating a blend shape that you don't add or remove any vertices to the mesh, as there's a unique number order that drives this deformer. To To demonstrate how blend shapes work, I'm going to open the Franklin production rig and I'm going to use the facial controls to make various facial expressions like a blink and different mouth shapes. After creating the first expression, I will then delete the history to unbind the head from the rig. I will do this by going into Edit, Delete by Type, History. I'll then go into the outliner and rename the head to something more descriptive about the blend shape. And then I will select and export the selected mesh as a new Maya file. Because all the heads of Franklin are the same and they have the same numbered vertices, I'll be able to create blend shapes in this unorthodox manner. I'll also undo all of the changes I just made, which will allow me to create another blend shape for the head. I'll repeat this process of posing and deleting the history to create some mouth shapes, and then a face that conveys some anger. However, I will have to export each eyebrow as its own blend shape, because the way that Franklin is constructed, each eyebrow is a separate mesh. In the Franklin GameRig file, I've now imported all the head meshes that I just made. I can hide them and then select all of the head meshes from the outliner, choosing Franklin's head last so it shows up green. When selected, then I can go to Deform, Blend Shapes, and choose the Options panel. In the Advanced tab, let's choose the deformation style to be pre-deformation to account for the skin deformer. We can now see the blend shape node in the attribute editor, or we can adjust the settings of the blend shapes in Windows, Animation Editor, Shape Editor. The Shape Editor will contain all of the blend shapes which are defined in the scene, and you can modify them by playing around with these sliders. I now have a very small selection of blend shapes that can help me animate the face by making Franklin blink, or I can create a library of several mouth shapes which in combination with the jawbone would allow me to pose the mouth in different ways. If we worked on every area of the face individually, in around some 50 blend shapes, we could create a large amount of animation possibilities for the entire face. But if we come into areas like the brow, where the eyebrows are separate from the mesh, they will have to have a separate collection of blend shapes too. Now, it should be possible to take the blend shapes and connect them through a single custom attribute, so that the brow blend shapes and the eyebrows move together. But this method won't copy over directly into Unreal, although it is possible that we could create Unreal blueprints that would have similar functionality. If you were creating a character from scratch, the normal way of creating blend shapes would be to select the mesh and go into the shape editor and create a new blend shape with a new target. Then once you're in edit mode, you can use any of Maya's modeling tools to sculpt the geometry. This could include sculpt brushes or just polygonal modeling. In this case, I'm just selecting a single vertex and using soft selection to move the brows around the face. The new blend shape will allow me to move the brows upwards, and if I made a small library of these, I could create almost any brow pose from a combination of 4 or 5 different blend shapes. Blend shapes can also be used to correct deformations on the rig. We can connect these in Maya to set-driven keys, and these will apply the blend shape as the leg bends. I don't think that set-driven keys will actually transfer over to Unreal, unfortunately. However, another method is that you can bake a blend shape out in a very similar way to how you bake out animation, and every single animation file could have its own blend shapes running with the mesh. If we export our Franklin rig one more time and come back to Unreal, we can now view all the blend shapes within the skeletal mesh. They are now a collection of values that we can dial in and hopefully control within Unreal. Now, I'm not an expert on programming or how to create game logic with blueprints, but it does seem that a lot of the tools that you could use inside of Maya to trigger blend shapes are also available inside of Unreal, but they seem to have a slightly different way of applying them. Now I can view all the animations that I made for Franklin, from his walk to his run and his idle. And with Unreal, I could try and blend all of these together using something that is conveniently named a blend space. A blend space is actually a little projection of animation where Unreal is trying to blend between different animation files depending of the speed at which a character is walking. Therefore, if I have a character in idle, he will play his idle animation, and it will gradually move into a slightly slower walk until it hits the walk speed, and then it can go all the way up into a run. And you'll see that without a lot of setup, you can actually blend all these animations together because Unreal is going between all the joint animation. So that's a quick overview to the rigging tools that I wanted to cover today. It still is very basic, but one of the key takeaways that I want you guys to take is that rigging is a long process. The more time you can dedicate into it, the more you will get out of it. It also pays to be organized and rename things, and saving constantly is an absolute must. Also, it's really useful to know the keyboard shortcuts and where all the tools are, because that will cut down your work time a lot. I'd like to thank Joshua Coate again for the Franklin rig, which has been really useful because it means that I haven't had to design a complete character from scratch, and it's also shown very well how you can take a game animation character all the way from Maya right into Engine. Now, this tutorial has gone on for quite a long time, but we haven't even covered some of the other tools which are inside of rigging, like how to create IK joint chains, how to create stretchy bones, how to create deformers, how to also create custom attributes with set-driven keys, or even dive into the dark recesses of the Maya node editor. If that is something that's interesting to you guys, then send me some comments below and we'll see what we'll be doing for our next rigging tutorial. If you like the channel and you want to support me as a creator, then really consider joining one of my Skillshare classes, or at least subscribe, hit the notification button, or leave me a comment in YouTube, as your support is really, really useful for helping me going and making these videos for you guys. So until next time, keep learning, stay strong, and I will catch you in the next video. Bye-bye.